Two lines that never intersect. All right. Now, does anyone know what a transversal is? A transversal line, I should say. It's a line that cuts through two parallel lines. All right. What happens with the transversal is that when it cuts through the parallel lines, the angles that get formed by it, actually have some pretty cool properties that happen to them. More often than not, two sets of angles will either be congruent or supplementary, depending on their position and where they are in terms of the transversal and the parallel lines. All right, so you'll hear a lot of alternate, same side, interior, exterior. All right. So let's actually look at what some of those properties are. So just a reminder, don't forget, supplementary angles, they add up to 180 degrees. And they make a straight line. All right. Now, before we go any further, if I were you guys, I would get out a couple of colors. If you don't have colors or anything, I got some on the shelf. But you're going to want like about 4 different colors. Whether it's colored pencils, highlighters, whatever, you need 4 different colors. Now, before we get into using all the different colors and stuff, before we get into that, all right, let's first discuss just some general geometric stuff. So how to name lines. Now, what you guys have done so far is that you've named them using 2 points. All right. But another way you can name them is using a singular lowercase letter. All right. So you see these little lowercase letters here? These are actually line names. So if I wanted to name the 2 parallel lines, what would those 2 parallel line names be? M and N. So the way you would write it is you would like lowercase m, and since it's a line, oh, my bad. It's frozen. You do a lowercase m, and since it's a line, not a line segment, you draw a little thingy over the top with arrows. All right, a line segment is just a line over the top. A line is a little line over the top with little arrows. It's just notation that tells you the difference. So we would say that line M is parallel to line N. Now, if you're naming a line with a singular letter, it has to be lowercase. Now, if you're naming it with points, those are uppercase. And it's one of those where, like English, how lowercase, uppercase matters, it also matters when it comes to naming things in geometry. All right. Now, what's the transversal name? P. Now, all of those numbers right there, those are different angles that we're going to be playing with and learning about the different properties of them. So, first things first, we're going to name and highlight all the vertical angles. So, first off, what's a vertical angle? What is it?
Two angles that are like the same because
they're congruent, but what does it look like picture-wise?
It looks like an X.
Yeah, it's like a cross or an X. It's basically 2 angles formed by 2 lines intersecting. All right. So someone raise their hand and tell me one set of vertical angles. Let's go, Fisher.
2 and 3.
2 and 3 is. So angle 2 is congruent to angle 3. All right, another set. Riley. 1 and 4. So angle 1 is congruent to angle 4. All right, Elizabeth. 5 and 8. So angle 5 is congruent to angle 8. And there's one more. Good. So, y'all were just waiting for that one. So, we'll get to that. So 6 is congruent to 7. Now, these are just the vertical angles. So Riley mentioned something. That's a different thing. But just remember, vertical angles are always congruent. So again, when it comes to parallel line properties, they're either going to be one of two things. They're either going to be congruent or they're going to be supplementary.
Isn't the supplementary what you were talking about?
Not quite. All right. The next set is alternate interior. Now, let's talk about this for a second. So when we're talking about the different parts of what this says, alternate interior, what do you think interior means in terms of the picture? Inside the what? The parallel line. So which angles do you think I'm going to be looking at?
5, 6, 3, and 4.
3, 4, 5, and 6. So interior, it means it's inside the parallel lines. So here's the interior. What do you think alternate means? Odin.
On the other side of the transfer.
Right, different sides of the transversal. All right. So alternate means different sides of the transversal. All right. So the thing is, alternate interior angles. Do you guys think they're going to be congruent or supplementary? Well, let's look at the placement. So, when I say alternate interior, all right, am I talking about 3, 4 or 3, 6?
3, 6.
3, 6. So, 3, 4, even though they're on different sides of the transversal, they're not alternate interior, they're a linear pair because they're adjacent to each other. Alternate interior angles are technically not adjacent to each other. Well, I guess they are because they do share a side. Nope, they're not. So they share a side, but they don't share a vertex. That's why they're not adjacent. All right. Whereas 3 and 4 are. So my alternate interior would be 3 and 6 and 5 and 4. Now, look at what they kind of look like. Do you think those angles are going to be congruent or supplementary? Congruent. Why do you think they're going to be congruent?
Because it's
It's almost like if, let's just say you did it as a circle. All right, let's say we found the midpoint between these angles. And we use that as like the middle of our circle. If we rotated this all the way around 180 degrees, it would end up being the exact same angle. All right. So that's a way that you can think about it. All right. And we know from unit 1, rotations are what type of motion? Rigid, which means what? Right. They only change their orientation or placement, but it still maintains the same size and same shape. All right. So that's a way you can think about it. They literally just rotated angle 3 to make angle 6. Same thing with 4 to 5. So 3 and 6 are congruent. 5 and 4 are congruent. So angle 4 is congruent to angle 5. Angle 3 is congruent to angle 6. So again, alternate interior, they're always congruent. Now, the whole rotation thing, that's actually something, when I was in college, something that I had to do in one of my education classes. And I wish I still had it, but it's on my personal computer. But one thing we had to do was actually use a program to make demonstrations of why those two angles would be congruent. And so what I actually did was, if you made a circle and you grabbed one of the angles and you rotated it, it would fall perfectly on top of the other one. All right, so that's another way you can think about it. So like I said, you can use the circle thing. It looks like it's just a rotation. All right, and we know rotations are rigid motions. Now, that's alternate interior. What about alternate exterior? So first off, we're talking about exterior. So what do I mean by exterior? Outside. Good. So if I'm talking outside the parallel lines, which angles do you think I'm playing with?
1, 2, 7.
1, 2, 7, and 8. Now, alternate, still the same thing we already talked about. It's opposite sides of the parallel line. So which do you think go together? 1 and 8, 2 and 7. Good. What do you think the relationship is? Congruent. They're still going to be congruent. So 2 is congruent to 7. 1's congruent to 8. So exterior is on the outside of the parallel lines. So angle 1 congruent to angle 8. Angle 2 congruent to angle 7. And again, if you wanted to maybe do like a demo on it, you could find the midpoint of the transversal and rotate angle 1 180 degrees, and it would fall right on angle 8. All right. And again, we know that rotations are rigid motions. So it's not just because some person said that they're going to be congruent. There's actual mathematical reason behind it. All right. The fact that we could rotate those angles around a point and land on that same angle, it's just a rigid motion. We know that rotations are congruent, make congruent figures. All right. So that's the alternates. All right. So alternate interior, alternate exterior. Regardless of whether it's interior or exterior, they're always congruent. Now, corresponding. So, corresponding is a little bit different. When you think of the word corresponding, what do you think of? Together. All right. Right. Okay, what else? So, together. All right. Now, if we're thinking about in terms of geometry, what would you think corresponding would be? So, for example, if I'm talking about corresponding sides on two different triangles, what do you think that would be? Pretty much the same location. All right. That's what corresponding means. It means it's in the same location of a similar figure. Pretty much. So, the way I think about this is that corresponding doesn't always mean that it's with congruent figures, but it does mean that they're in the same spot. All right. So, for example, with the warm-up that we did on our boards, all right, if you actually looked at the baby triangle formed by the mid-segment and then the whole big triangle, XY and UV are actually corresponding sides. All right, they're in the same spot on these similar triangles. All right. Now, we'll get deeper into that when we get to similarity, but all it means is same position. All right? So, if we're talking about parallel lines, think about it as if there's an invisible third line separating these two. You're just looking at each one individually. Someone name me one set of angles that appear to be in the same spot if you look at these two things individually.
1 and 7.
1 and 7's a pair. Actually, no, it's not 1 and 7. It's 1 and 5. 2 and 6 is another one. What's another one? 3 and 7. 4 and 8. So basically what I'm saying is, this is almost like a translation. If I took this point right here and I translated down however many units, it should land perfectly on top of the other one. So the corresponding are the angles that would overlap if you translated it. All right. I'm just pulling stuff back from what we did in the previous unit. So 1 and 5 are corresponding. 3 and 7 are corresponding. 2 and 6. And 4 and 8. Now, if they're in this exact same spot, what do you think they are measurement-wise? They're the same or congruent. Thank you. All right. So, angle 4 congruent to angle 8. Angle 3 is congruent to angle 7. Angle 1 is congruent to angle 5. And angle 4, I already said that one. Angle 2 is congruent to angle 6. So they're always going to be congruent. Why do you think that is? I kind of already said it, but why do you think that is? So someone already trying to tell me why. Someone that's preferably not spoken today. So why do you think they're going to always be congruent? Okay, let's go with Charlie.
Because the line going through, there are two parallel lines that are run to this, so like that's what's created corresponding.
Kind of. Anyone else got a thought? 8.
And he goes in the exact same spot across the two shears.
They're in the exact same spot, but how do we know they're in the exact same spot? Fisher.
Because if we slid the top line down or the bottom line up, they would be in the exact same spot.
Right. So again, like I said earlier, translation, move it on down or slightly to the side. You might have to because it's kind of on a diagonal. If you translate it, which we know translation is just a shift, it will just move right on top of each other. All right. So that's why we know that they're always congruent, because if it lands perfectly on top of the other, it has to be the same. Now, here's a couple more. I think these are the ones that got cut off. So wherever you have space, just redraw these. Yeah, I think there's some space. They are on the other side. Okay.
5 and 6 got cut off.
Okay, as long as you drew them like up top on that space, that's probably a good idea.
There was a space like on the next page.
Yeah.
That like was just blank, so that's where I wanted.
Yeah, we didn't notice that until after we printed the packets, and they're so big we didn't want to waste the paper. It's like we'll fix it in post. All right, so now we're back to interior exterior, but instead of alternate, now we're talking about same side. Does anyone know what another name for same side is? It's one word. Say it again.
Similar.
Not quite. I'll give you a hint. It starts with a C.
Congruent.
Symmetric.
Not correlation.
Symmetric.
Nope.
Oh.
Not quite.
Close.
So I just want to see if you knew it or not. It's consecutive. All right. So consecutive. Another name for same side. You may see it switched around a lot. Another name for same side, just so you're aware, is consecutive. You may see it as both of these words. You may see same side interior. You may see consecutive interior. Just know they mean the exact same thing. All right. Little vocab right there for you. Okay, so we're talking same side interior. So first off, interior, we know that's inside. So what angles am I playing with?
3, 4, 5, 6.
3, 4, 5, 6. Good. Now, if we're talking same side, what do I mean by that?
On the same side of the.
They're on the same side of the transversal. So that being said, which angles do you think are going to be kind of together? 4 and 6 and 3 and 5. Now, I don't know why I made that a different color. Now, what relationship do you think these angles have? Are they going to be congruent or supplementary? Supplementary. Can anyone give me an idea of why they would be supplementary? Someone who has not spoken at all today. So, Riley, you've been carrying. Abby, what do you think?
So we know that 4 is congruent to 5, and that's on the same line as 6. So they would.
True. So we know that 3 and 6 are congruent. We know that 4 and 5 are congruent. We also know that 3, 4 would be supplementary because they're a linear pair. Same thing with 5 and 6. So couldn't we, by substitution, replace the 3 in this case is connected to the 4 with the 6 because they're congruent? We can. All right. So that's why that these are supplementary. All right, because we have two sets of congruent angles, but we know that these two angles aren't congruent, but the sets of congruent angles are connected to a linear pair. All right, that are also has a set that are congruent to each other. So, in other words, they're supplementary. Which was supplementary mean again? Adds to 180. So angle 4 plus angle 6 is 180 degrees. Angle 3 plus angle 5 is 180 degrees. So same side interior or consecutive interior are always supplementary. Now, that's the interior side of it. So guess what they also have? Exterior. So very similar to same side interior, but since I'm talking about exterior, what angles am I playing with? 1, 2, 7, and 8. All right. Now, same side, still need same side of the transversal. So which do you think are going together? 1 and 7, 2 and 8. So, same thing. They're still going to be supplementary because we know that 2, 7 is congruent. We know that 1, 8 is congruent. And we also know that 1, 2 is a linear pair. So by substitution, they're supplementary. Which, by the way, that's kind of a proof trick, which we'll get to later. All right. Sometimes if you can prove that something is congruent to another thing, and something else is congruent to another thing, and then that two of those things you prove that are congruent are supplementary, you can move things around. That's called either the transitive property or substitution, being the same thing. So we would say that angle 2 plus angle 8 is equal to 180 degrees. Angle 1 plus angle 7 is 180 degrees. They're always going to be supplementary. So again, when it comes to parallel lines, you got about a 50-50 shot of getting it right. They're always good, regardless of where they are, they're always going to be either supplementary or congruent. Now you got like a 50-50 shot. You just got to make sure you pick the right one. Okay? Now, right here, it's kind of just a restating, but let's actually try finding some angles. So I love these kinds of problems because, like, kind of like yesterday, they're almost like a big old puzzle. All right, they give you usually one angle to start with, and you kind of have to work your way around, kind of like what we did yesterday. So for this problem, they told us angle 1 is 120 degrees. All right, so I'm just going to go ahead and label that. Angle 1 is 120 degrees. Now, they want us to find the other 7. So based off of what you know about parallel lines now, I want you guys to take a minute or two, probably take about 2-3 minutes, and figure out what the other 7 angles are on your own. So don't discuss with your group. Try it on your own. So use what we just learned about those parallel lines. Figure out what the rest of those angles are. All right, got about a minute left. All right, looks like most of you are finished, but take a minute, compare your answers with your group.
Did you get this?
All right, let's come back together. All right, so come back together. Heard some nice discourse there, so that's always a good thing. All right, so what we're going to do is I'm going to call a name, and you're going to tell me what you got for that angle and how it relates to angle 1, if it relates to angle 1. All right. So let's go with Colin to start us off. So angle 2. What is the measure of angle 2?
60 degrees.
And what is the connection to angle 1?
It's
forgot what it's called, but it's on the same line, so it has to equal 100.
Right, so it's supplementary. It's called a linear pair. All right. And it would help if I unfroze the screen. So, this is because it's a linear pair. Colin, pick someone to go next. All right, Odin, what'd you get for 3?
I got 60 because it's across from 2.
So 60 because it's a vertical angle to 2, but how does it connect to angle 1?
It's also supplementary with 1.
Right?
Oh, equal
Why?
80. Because 120 plus 60 equals 80.
True, but what is it?
It's a linear.
It's a linear pair. So it's a linear pair, it's just vertical instead of horizontal. If you turn your paper, it would look like what 1 and 2 look like. All right. Odin, pick someone for 4. All right. Carson, what's 4? Why? What's the connection to 1? So what's the actual name for that type of angle? Shh. Starts with a V. Vertical. They're vertical angles. All right, so they are vertical. All right, Carson, pick someone for 5. So 5 is what? Okay. Okay, good. It is 120. Why? What's the relation to 1?
It is a corresponding.
Good. It's corresponding. It's in the same spot. All right. Ross, pick someone for 6.
I got 60 degrees.
Okay. Now, first off, is there a direct relationship to 1? With 1 and 6? So does any of the rules that we covered connect it back to 1?
No.
No. All right. 1 is exterior, 6 is interior. They're not in the same spot, so they're not corresponding, and they're not vertical or directly a linear pair. However, this is where that substitution comes into play. All right. Because we know that 1 and 5 are congruent because of them being corresponding. And we know that 3 and 6 are congruent because of alternate interior angles. All right. So because 1 and 5 are congruent, 3 and 6 are congruent, and we know that 1 and 3 are supplementary, by substitution, if we replace the 3 with the 6, that means that they're also supplementary. So this would be 60 degrees, and the connection the connection to it to 1 would be by substitution. It would help if I could actually spell the word correctly. Substitution. Oh my god. I still probably spelled it wrong. This is why I'm a math teacher, guys, not an English teacher. All right. Peyton, pick someone for 7. All right, Abe, what'd you get for 7?
60 degrees.
60 degrees. And is there a direct connection between 1 and 7? You sure?
Yes. Supplementary.
They're supplementary, but why are they supplementary? What's the correlation?
They're the same side.
They're same side. Exterior, good. So they're same side exterior. Guys, I know that a lot of you know it, but don't shout it out unless I call on you, okay? So same side exterior, which we know to be supplementary. All right. Abe, pick someone for the last one. All right, Allison, what's 8? 120. And what's the connection to 1? Okay, well, look back at the previous. What's the positions?
They're alternate interior or exterior.
Alternate exterior. Good. So, guys, I don't mind if, like, I call on you and you got to take a second to look back at your notes. It's okay. All right, but I want to really drill that vocabulary into you because on a test, that's what's going to be used. All right, so you need to know that vocabulary. It's important. So these are alternate exterior. All right, so I'm pretty confident y'all can handle the next one. So let's do a little bit more here. So now let's do some identifying. So we're going to do a little bit of a game, so to speak. All right. So we're going to say whether they're corresponding, alternate interior, alternate exterior, vertical, same side interior, or same side exterior. So we're going to do this in terms of fingers. So if you hold up one finger, it's corresponding. 2, it's alternate interior. 3, it's alternate exterior. 4 is vertical. 5 is same side interior. 6 is exterior. You may want to write that on your paper because when I scroll down, it may not.
It's got cut off.
Yeah.
I mean,
Like we don't have all.
It's okay. It's okay. So I'll just freeze that. Okay. And then we'll just do it based off of numbers. Okay. All right. So the words got cut off, but the examples didn't.
Yeah.
Okay. So I'll leave that up there because y'all got it in front of you. Okay. So, by a show of fingers, number 1. Take a minute to think about it. Don't raise this yet. Number 1. Y and X are related by what postulate? Don't hold them up just yet. Take a minute. Think about it. All right, raise in 3, 2, 1. Good job. They are corresponding. Oops, sorry. All right. So number 1 is corresponding. Make sure you write that next to it. What about numero dos? Or number 2? Number 2, think about it. What relationship are those two angles X and Y? Don't discuss with your group. I want to see if y'all can do it on your own. Look back at your notes if you need to. It's okay. All right. Raise in 3, 2, 1. Good. They are corresponding again. All right. Look at number 3 on your paper. I'm not going to scroll up. I'll just leave this up there so you know the finger numbers. So number 3, take a look at it. Think about what the relationship is. So you need to look at it on your paper because I'm freezing so you know the counts. Think about it. Don't discuss. Don't discuss. See if you can do it on your own. You don't have your friends on your test. All right. Raise in 3, 2, 1. Good job. It is alternate interior. All right. So we're going to skip 4 because it's going to be the exact same. But look at 5. So look at number 5. Think about it. What's the relationship? All right. Raise in 3, 2, 1, go. Good. It is corresponding. All right. Lastly, number 6. Look at it. Give it a thinker. All right. Think about the position. All right. 3, 2, 1. Raise it. Good job, guys. It is same side interior. What's another name for same side interior? Not corresponding. Consecutive. Good. So maybe make a note that you can also write it as consecutive. Now, this wouldn't be a Math 2 class if we didn't throw some algebra into it. All right. So what we've been doing up until right now, you guys learned in, I think, 7th grade. All right. So let's put a little bit more of a zing to it. Let's throw some X's in there. All right. So do you guys have this example maybe on the next page? Okay. So they stated that line L and M are parallel. They use a little parallel symbol. The measure of angle 1 is 3x plus 16, and the measure of angle 2 is x plus 12. So what I suggest doing, go ahead and write in those expressions on the picture. Now, before we do anything in terms of solving, we first want to identify the relationship. If we know what the relationship is, we can then conclude how we set up our actual equation. So, take a minute, think about what the relationship between 1 and 2 is. And then when you're ready, someone raise their hand and tell me what that relationship is. All right, let's go, Roberto. What do you think it is? Good, it's same side interior. So 1 and 2 is same side interior. So Maxton, what does that mean the two angles are? So would they be congruent or supplementary? Supplementary. So just note that they're going to be supplementary. Now, where that comes into play is when we solve for x, because how do you think I'm going to use those two expressions to set up an equation? We're going to add them up, equal them to 180. Good. All right, take a minute on your own, finish solving for x. So now that you got the equation, finish solving for x. Just x. All right, thumbs up if you're ready. You guys, one more minute. Just solve for x. Don't do let part C yet. Just solve for x. That's all I want. All right. Let's go with Abe. What'd you get for x? Good. So x should have equaled 38. Now, they then ask us to, oops, sorry guys. They then ask us to find the measure of angle 1 and the measure of angle 2. By the way, if you see a little M in front of like the little angle symbol, it means measure. All right. So, what do I do to get those two measures? Plug it back in into x individually. Now, do I only need to do it for one of them or both? Why both? Well, not just because they're asking for both, but because they are going to be, are they going to be the same or different measures? Different. So we do 3 times 38 plus 16. That equals angle 1. Then angle 2 is going to be 38 plus 12. So angle 2 should give you 50 degrees. Angle 1 should give you 130 degrees. Take a minute, double check in your calculator if my math's right. All right. Now, is it true that 130 plus 50 is 180 degrees? Yeah. So guys, my recommendation, take the extra second and check to see if your answers actually do what it's supposed to do in terms of the theorems. We know that they're supposed to be supplementary. If they're not supplementary, meaning they don't add to 180, probably something you did wrong there. All right, last thing we're going to do is we're going to do my favorite, the puzzle. All right, so look at this big picture here. This is one of those where we kind of got to work our way around again, but we're not just going to be using parallel line theorems. We're going to also include some of the stuff we learned yesterday. All right. So they stated that line Q is parallel to M. So these two are parallel. So I'm just going to mark them with the arrows just so I know that they're parallel. Those are the only set of parallel lines. So that means these two lines would be what to those parallel lines? What's the name for these two lines? Not perpendicular. Nope. We talked about it at the beginning of class today. What's the name for these lines? I heard it. Transversal. They're transversals. All right. So you could start in a couple of different places. There's only really 2 places that I would consider starting, and maybe 3. Someone just pick one of the angles that they think will be a good place to start. I would do 7 first. 3. All right, I heard 3. Let's go with 3. And no, 3 ain't that good either. Let's do 2. Let's do 2. All right, so look at 2. What's the connection, or what angle does it connect to that we know? 115. What's true about those 2? They're supplementary. So what's angle 2? 65. All right. Where can I go next? We can go to 3 next. What's the connection between 3 and what angle? 2. What's the connection? They're congruent. Why? They're corresponding. Good. So that means that 3 is also 65 degrees. Pick another angle. What can we do now? Still can't do 7 yet. I'll do 4. Now, what connection do you want to put with 4? 115. All right. What's the connection? They're corresponding, so they're congruent. You could have also connected to 3, saying that it's supplementary, done it that way. All right. Okay, so that's kind of this pod. Pick another angle that we can definitely get. I would definitely do 1 next. All right. So 1, what's its connection? It's connected to 110. How? Why? What are they called? Linear pair. Good. So they're supplementary because they're a linear pair. So what's 1? 70. What angle can I find now? Now you can find 7. Why? You can add them up to get 180 because we got ourselves a wee triangle here. And we know 2 of the angles. So if you add up 65 and 70, subtract it from 180, what do you get for 7? 45. What can I find now? 6. What's the connection to 6? 2, 7. So 6 is also 45. So that leaves us with 5. What can I connect with 5? It's corresponding to what? Corresponding to 7. And it's also what? Alternate interior to 6. Either way, it's congruent, so that's also 45 degrees. So guys, my suggestion when it comes to these look for very, very obvious placements. So for example, I would have either started with 1 or 2. Those would have been the ones I would have automatically gone for. Just because linear pairs is what we already knew. Because then once we get those, it's pretty easy to work your way the rest of the way around. All right, any questions on any of this stuff? All right, so you guys got another Delta math assigned to you. It's pretty brief. It's just this stuff. It'll be due tomorrow by midnight. Listen, you guys got a solid little over 20 minutes to work through that. It's actually 25. Due tonight by midnight. So the Delta math from yesterday is due tonight by midnight. So if you didn't finish it, it's okay. You can work on it now. So guys, get to work. Use this time wisely. You don't get it too often. Come on, guys, get to work. I shouldn't be hearing a lot of talking. By the way, all your grades have been updated except for the journal grades. Those are going in probably like right now. But everything else, all the Delta maths and the paper assignments from before the Unit 1 test, those are currently in Infinite Campus. Yes.
I'm that close.